Thank you, Chris. Thank you, Mawe, and thank you all for inviting me. I hear everyone leaves at 1 o'clock, so I've got my clock here so that we have time for some questions. Well, I think everyone here has noticed that we have a trash problem in our city. And if you've traveled to other cities, we have trash problems there too. That's a picture on Thomas Delpit Drive, but you can find scenes like that throughout our city and the surrounding parish. And all of this trash, which is largely plastic, is really only 1 or 2 rainfalls away from making its way into our waterways and into the Gulf of Mexico. You can see it in the booms that the city has across the Corporation Canal at the beginning of Bayou du Plantier, and this stuff gets retained. It doesn't get picked up very frequently, and the next rainfall just moves it on down until it makes its way to the Gulf of Mexico. In 2015, I took a group of students out into the Gulf of Mexico for a 24-hour classroom research cruise, and during that time we took a look at microplastics in the area. Nobody had looked for microplastics in the Gulf of Mexico. I'll talk more about what they are in a second. But when we hauled in our nets, we could immediately see large concentrations of microplastic. And if you've been to the beaches along the Louisiana coast down to Elmer's Island or a place like that, Grand Isle, you can see micro and macroplastic in abundance. So microplastics are plastics about the size of a Mardi Gras bead, 5 millimeters or less. That's the operational definition of a microplastic. And here you can see some micro beads. We collected these from the Mississippi River. They're on the face of a penny. So they can be extremely small, and they can continue on down to the size where you really need a microscope or even an electron microscope to see them. Plastics, or microplastics, originate from a number of sources. The first is fragmentation of macroplastics. So when plastic is exposed to sunlight, the plasticizers in the plastic, which are the compounds that give it its texture, its ductility, its flexibility, they start to break down under ultraviolet light, and this makes the plastic brittle. And so then the plastic is vulnerable to mechanical fragmentation when it's tumbled around, when a car goes over it, when you run your lawnmower over it. And any piece of large plastic starts a process when it gets into the environment of continual fragmentation, and it moves down into micro and then really, really small microplastic fragments. Another source is bead blasting, much like sand blasting. You can go to Lowe's, you can buy a 5-gallon bucket of plastic pellets, and these can be sprayed to remove corrosion. They're often used in the marine industry, and of course they're spraying it into water bodies. Raw plastic resin pellets, or nurdles, they've been in the news a lot lately. These are the precursors for plastics, so these are pure polystyrene or polyethylene, and these are what are melted down, added to plasticizers, colorants, and put into injection molds, and out pops, a cell phone case or something like that. Whenever nurdles are handled and transshipped, they are spilled. Tires are largely made of plastic. There's rubber in them, but there's also a lot of polymer, so when you lay a patch of rubber, you're really laying a patch of plastic, and so the tire fragments, as your tires wear down, get on the roads and then get washed into our drains and into our waterways. A big one is laundering of synthetic garments. So a lot of our fabrics now are made of polyethylene terephthalate or nylon, and so the lint that you pull out of your dryer, an even larger quantity of lint goes out with the rinse cycle. And so these tiny fragments, which pass through most screens and systems designed to prevent plastic from getting into our waterways, they pass through and they get into our waterways. A lot of personal care products in the US used to have abrasive plastic beads in them. Things like that Neutrogena face scrub. In 2018 they were outlawed, but they can still be present in prescription products, and they can still be found in products that are old or products that are sold outside of the United States. And then finally, paint. Paints are largely made of plastics now, and so paint flakes are plastic flakes. So these are the main sources of microplastics. And when you look at a microplastic, so this is a picture I took in a microscope in my lab. It probably was a styrofoam cup, part of a styrofoam cup at one point, but now it's just a millimeter or so across. you can see that there's a lot of surface area relative to the size of this object and lots of nooks and crannies. And so that surface area combined with the hydrophobic nature of plastics, if you put water on plastic, it beads up. That's because it's hydrophobic, it repels water. Well, hydrophobic compounds are very attractive to organic molecules like herbicides, pesticides, polyaromatic hydrocarbons, DDT, things like that. They will stick to the surface of these plastics. And so over time, that little piece of styrofoam will build up a load of organic pollutants on the surface and in all the nooks and crannies on its surface. And so these plastics are acting as like a little Uber, and they're transporting all these nasty compounds with them down into our oceans and into our rivers and our oceans. So why would a fish eat something that's covered with all that nasty gunk? Well, there's something interesting that happens to these plastics over time. So when a piece of plastic enters the water, over a process of about 2 months, the surface of that plastic gets colonized by microbes. And those microbes produce a compound called dimethyl sulfide. Dimethyl sulfide, or DMS, you've all smelt it. It's the smell of the sea. It's that salty smell. It's naturally produced by marine phytoplankton. Seabirds use the smell of DMS to locate patches of phytoplankton where they can likely forage for small fish like anchovies. And so it doesn't take long for this little piece of plastic to start to smell and taste like natural food. And so that piece of plastic can then be mistaken by a little fish for something that is actually good to eat. But of course it's not, because it's not digestible. It's got all this organic pollutant load on it, which is taken up by the animal, and it can block the digestive tract. When a bigger fish eats the small fish, then these things accumulate, much in the same way that mercury accumulates as you move up the food web in large tunas. So in the lower pictures here, those yellowish ones, these are fibers. Remember those fabrics I was talking about that come out in your washing machine? These are from a little fish called an Atlantic bumper. It eats zooplankton. We collected it from Terrebonne Bay, and its stomach was completely packed with fibers of synthetic plastic. And every fish that we pulled out of Terrebonne Bay that ate zooplankton, we didn't look at the other ones, had all these fibers jammed in their stomachs. So this stuff is getting into the environment, it's getting into small forage fish, and bigger fish like redfish eat them. And of course, then people who eat fish are potentially ingesting this load of organic pollutants that are inside the tissue of the fish. So I mentioned that we went out and we looked at microplastics in the Gulf of Mexico. These are just numbers, particles per cubic meter. Dark blue is one kind of a net, the light blue is a net that's right at the surface, and these are the numbers that we get. When we compare them to numbers from places like the Great Pacific Garbage Patch or other gyres or inland seas where circulation will concentrate plastics, we can see that we've got numbers that are as high or higher than the hotspots that the media always talks about. Well, the question that arose was, where are these plastics coming from? Because I mean, the coast of Louisiana is not heavily populated. I can't imagine that these high densities are coming from people in Houma or Morgan City. And the reality is they're coming from the entire United States, or almost the entire United States. The Mississippi River drainage basin is home to over 100 million people. And there are cities just like Baton Rouge that have the same problems that we have with trash, and all the lint, all the paint flakes and other sources of plastic are coming down our river and moving out into the Gulf of Mexico, and we were sampling in the plume of the Mississippi River. So we designed a project, we got some funding from Sea Grant, to take a look at microplastics in the Mississippi River. And so we set up 5 stations, 3 of them bracketed Baton Rouge, 2 of them bracketed New Orleans. So we had one upstream of the Old River Bridge. We had one about in line with LSU and one just below L'Auberge Casino. And then we had one near the 310 bridge near Norco, and one down by Belle Chase. And so we would go out to those quarterly, and we'd tow a net in a small boat across the river. We would do 4 transects across the river. Each one of them would yield a sample, and we would count the plastics, we'd measure the volume of water that we collected. And it was a real challenge because the lower Mississippi is not really a friendly place for a small boat. And so you don't see Boston whalers out there. And every time we were out there, you know, people would come up, do you need help? Is something wrong? No, we're good. Plus you're trying to move in and out of the way of these large ships that are going up and down the river. So when we pulled our samples in, there's a typical sample. You can see there's a bottle cap in there, there's some nurdles, there's lots and lots of plastic. And when you put it in a jar, all the little pieces of styrofoam come up to the surface. So we took our average numbers and we multiplied them by the flux, the flow rate of the river, and you get a plot like this. So this shows the daily microplastic flux between 0.5 millimeters, which was the smallest size we measured, and 5 millimeters, which was the largest size. And so we're up in the billions of particles per day. And if you add that up and sum it over a year, you get a mean annual estimate of about 325 billion particles between 0.5 and 5 millimeters being fluxed annually out of the river. And this is almost certainly a gross underestimate, because if we look at the abundance of our different sizes, those are just the midpoints of our three size categories. We had 0.5 to 2 millimeters, 2 to 4 millimeters, 4 to 5 millimeters. You can see that the abundance goes up almost exponentially. So if we were to extrapolate down to the really, really small particles, we're certainly talking about trillions or hundreds of trillions of particles being fluxed into the Gulf of Mexico. We are all probably aware of the loss of land in Louisiana and the Coastal Master Plan, which involves diverting river from the Mississippi River into our coastal wetlands to allow sediments to rebuild land. That's the riverside intake of the Davis Pond diversion, which was near one of our sampling sites. And it's an incredible mass of woody debris and plastic. And so we went out and sampled that area, and we put our net into the outfall of the Davis Pond diversion. The plot on the right just shows the flow rate during the time that we were there, and the black areas are where we took samples. And the bottom is actually a movie, if you can play that, the bottom. We asked them to bump the flow rate up a little bit, and when they did that, the quantity of plastic that came rushing out of that outfall was staggering. And so it looks, you can see the wood, but there's tons of plastic coming out of there. Oops. And that's from one 15-minute sample. Those are nurdles, fragments, beads, all kinds of different plastics that we collected in a 15-minute sample. So remember those fish I showed you the stomach of from Terrebonne Bay? I mean, we have to rebuild our coast, but we need to consider the consequences of having so much microplastic fluxing into the bays where we have nursery grounds for a lot of our fish. And if you do an estimate just based on that particular sample, that would be the equivalent of over 388 million particles per day being fluxed out of that one diversion. We've done some other things. The folks at L'Auberge Casino were kind enough to let me turn their roof into kind of a little drone heliport. And so we flew a drone almost several times a week for several months over the river at low altitude, taking pictures of the surface. And we were trying to map the plastic that was fluxing down the river, but it's a real challenge because the drone has to be low enough to get a clear picture of the water, and there's a lot of foam in the river, and that foam looks a lot like plastic. So it became very difficult for us to distinguish plastic from foam. So science doesn't always work out the way you hope it's going to. But we did turn our drone into a different project, and so we entered into a competition that the National Geographic Society had called the Ocean Plastic Innovation Challenge. And we focused on the remote barrier islands along our coast and used the drone to map the plastic debris on those barrier islands. And so this is a short video that I'll play for you. You can start the video, that we submitted to National Geographic. And this video, we wound up being semi-finalists in this competition in the data visualization category. So unfortunately, we weren't the winners of that competition, but we were semifinalists, and we were in great company. We got to go to DC and present all this, so it was really an exciting opportunity. But it's really depressing to go out to our remote islands where you really can only get to them by boat and see the litter from 100 million people's worth of trash deposited on those islands. And we could clean up that trash, and I guarantee you could go back a week or two later and you wouldn't know the difference. So we've got to do something to stop the plastic from fluxing into the river in the first place. I'm going to tell you now, I'm going to end up with just a story of a recent spill. So about a year ago in New Orleans, a ship called the Bianca broke loose from its moorings and lost some shipping containers. One of those 40-foot containers was filled with plastic nurdles, and those nurdles entered the river. And this was a substantial spill, so that's down by Governor Nichols Wharf, just across from Café du Monde. And so we went out with a team and we sampled along the river down as far as Belle Chase. And we were trying to estimate how much was out there. The shipping company lawyered up, they wouldn't tell us or anybody how much was spilled. But in 2017, there was a spill of nurdles in Durban Harbor, South Africa, and the nurdles were packed in 25-kilogram sacks in a 40-foot shipping container. Well, that's one of the sacks we recovered. They're 25-kilogram sacks, so we know that a shipping container can hold 990 of those. And so we estimated, doing some simple math, about 750 million nurdles were spilt into the river. So where did they go? Well, this is high-density polyethylene. It floats, so the majority of them probably entered the Gulf of Mexico very quickly, but large amounts were deposited along the shoreline between the Crescent City Connection Bridge and probably the mouth of the river. And so we went out with quadrats, we counted them, we cleaned and dried the samples, we had students sort all the wood and other debris out, and we're in the process of putting together a paper on exactly how many nurdles were deposited. And you can see, this is down at Chalmette Battlefield. This is, you can see over time, there was a fairly rapid decline as the river rose up and remobilized these nurdles, but they're still out there today. A colleague of mine went down there a few weeks ago, and there are still nurdles from the spill on the shoreline. But what was really intriguing was the number of other nurdles we discovered. So we really discovered that, in fact, there's a paper we're going to write called "A Nurdle in a Haystack" as a title, but we discovered that there's a chronic nurdle pollution problem in the lower Mississippi River from all these other nurdles. We went down to Elmer's Island and found evidence of a massive nurdle spill. And while these nurdles matched spectrally the ones from our spill, their shape was completely different. So here was another spill of unknown origin that we documented down there. So that's very much a work in progress. More recent work that we've done, and this involves Rotary, in April, the Mississippi River Cities and Towns Initiative, which is a group that involves all the mayors of communities along the Mississippi. They partnered with Rotary, and we had St. Louis, Baton Rouge, and St. Paul, Minnesota were selected as demonstration cities. And one of the things we did was release satellite tagged bottles, water bottles with a satellite GPS tracker in them. These were developed by Dr. Jenna Jambeck at the University of Georgia, and Jenna and I are working on a collaboration to expand this project. Well, one of those bottles made its way all the way from St. Louis to West Baton Rouge, where it was found by that gentleman when he was fishing. And so we recovered it, recharged the battery, refurbished it, and he went out in the river courtesy of Shamrock Marine, and we put it back in the river and sent it further down the river. Unfortunately, it got as far as Bruisley and got caught up in some barges, and that was the last we were able to hear from it. But we have plans to use more of this technology. So I'll wrap up by just saying that plastic is a ubiquitous sign of civilization. And I'm going to end with this anecdote. When the folks who put together this zombie apocalypse series, Fear the Walking Dead, the set designers were asked how they transformed Los Angeles into this post-apocalyptic wasteland where people were gone. And they said, we just picked up some of the trash. So I'll stop there with acknowledgments to these folks, and I'll be happy to take any questions.
When you were speaking, I walked out to get a cup of coffee, and then thoughtlessly noticed that instead of grabbing the cup, I grabbing a ceramic cup, I grabbed the styrofoam, so I sheepishly halfway into sitting down, I said, oh my God, the irony.
Yeah.
My question is twofold. What is the single most important thing that we as individuals can do to help make the situation better? And then what do you see in the future in terms of technology and large-scale remediation solutions that can help make this better?
Yeah, so those are both complex questions. I'll answer the first one, which is what can we do individually? I think there are a number of things, but we need to be conscious of the amount of plastic that we use. And so that means instead of having styrofoam cups, you have ceramic cups, which can be cleaned, or buy yourself a water bottle or a reusable cup. Take opportunities to minimize your interaction and use of plastics wherever those opportunities afford themselves. So when you go to a coffee shop, take something that can be filled up. When you go to the supermarket, bring a bag where you can put your groceries into it, your vegetables and fruits. I realized during COVID, a lot of grocery stores are resistant to the idea of people bringing in reusable bags, so that's a challenge. The other thing is there are simple things. You can put filters on your washing machines, which will collect the lint, and then you can dispose of the lint in the trash. Recycle where you can, and we have mixed recycling in Baton Rouge, which means we put everything into a bin. I've been to the MRF, the recycling facility, and they spend so much time taking things out of there that don't belong in there. We can really only recycle polyethylene terephthalate and high-density polyethylene, sometimes polystyrene. The other plastics need to go in the trash. They're not recyclable right now. In terms of technology, that's a real challenge. There are vending machines. I know when I lived in Massachusetts, I could take my soda bottles and plastic bottles and I could put them into a machine that read the barcode on them, identified the polymer, crushed them, and spit out a receipt that I could take and exchange for cash. So we need to have a deposit, I believe, on commonly used plastic items like water bottles. We should have refilling stations on water fountains. You can see them at the Baton Rouge airport, most airports now, most schools have them. So that's a simple technology to avoid using water fountains and encourage people to refill containers. There are sophisticated trash booms. In Lafayette, on the river there, they have a device that skims all the plastic from the rivers and collects it, puts it into a shipping container, and they empty that out and remove it. So that, and then the final thing I would say is if you see a piece of trash on the ground, I don't imagine anyone here would litter, but if you see trash on the ground, pick it up. Because if you leave it there, it's going to get fragmented and it's going to become a million little pieces of microplastic in the oceans.
I've got, I guess, a twofold question. The first part has to do with recycling. How efficient is recycling, and how much of these, polystyrenes and things like this break down between when I put it in the recycling bin and it gets to its final destination? And I guess the second part of that question would be how quickly does plastic break down? And because I've heard some plastic lasts for thousands of years. Can you talk about the differences in types
Right,
of plastic?
right. So if you're putting polystyrene in your recycling bin, it's not going to be recycled. It's not recyclable. Again, only high-density polyethylene, polyethylene terephthalate, which are water bottles. And
layman's terms.
yeah, so, but most of that plastic is sorted at the MRF here and is bundled, palletized, and sent off, and is probably back on the shelves within 1 to 2 weeks as a new product. So it's ground up. So the ones that can be recycled, that's great. The other plastics, there used to be a market for them in China, but our recycling is quite dirty, and so the plastic was contaminated with food and other residues, and so they would not tend to take that plastic. And so that market is closed to us now, along with deteriorating relations with China. It just hasn't helped things. So a lot of plastic that used to be recycled is now not economically recyclable and goes into landfills. The second part of your question was how long does plastic last? So you're correct, it can last from hundreds to thousands of years, but it is going to go through this process of fragmentation. There's been some recent work by Chris Reddy at Woods Hole Oceanographic Institution looking at expanded polystyrene, so styrofoam, and they found that under certain conditions it can break down quite rapidly in the order of a few years. But in general, most of these plastics are going to outlive you, your kids, and your grandchildren. So it's a long-term problem.
Hello? Over here.
Okay.
I've got a question for you.
Okay.
The environmental groups put a lot of pressure on energy companies to go green and whatnot. Is there any concerted effort on the use of plastic packaging by these national companies that sell goods and stuff like that?
So yeah, the question is there any effort to encourage or reduce the use of plastic packaging? There are lots of grassroots initiatives to encourage that. There are a lot of environmental organizations, but it is extremely difficult, and there's a lot of resistance to that. It's become somewhat politicized as well. In some states, local municipalities have passed laws against moratoriums on plastic packaging and restricting the use of deposits or some sort of fee for a disposable plastic bag. The other challenge is that plastic packaging, in meats and a lot of the stuff that you get in the grocery stores, our whole supply chain is designed to have that stuff shipped in that manner. And so having it shipped, in bulk and sold without that packaging, we're just not geared up for it. So there are a lot of people who want to see it. The Europeans are ahead of us on this, but we're not there yet, not even close. Yes, sir.
Yeah, can you explain to us some of the challenges with cigarette butts and pollutants that they have?
Yeah, so cigarette butts, you see them everywhere, particularly intersections where there's, a left turn that you're waiting for. And everyone seems to think it's okay. And they're small, and, people don't even notice small plastic. Just anecdotally, you go to LSU after a football game and they clean up the big plastic, but all the little plastic's still out there and nobody notices it. So cigarette butts are made up of a matrix of plastic fibers that trap the tars and other organic residues from the burnt tobacco. And so over time, those things are going to be mechanically broken down along with the effects of ultraviolet light. Cars are driving over them, and all those are contributing to these little microfibers. They're already coated with these organic pollutants, but then they can pick up other ones when they go down the river. Yeah, so cigarette butts, they're the #1 item that have been found on beach cleanups around the world. It's cigarette butts. Yeah. Yeah.
So, what really are nurdles used for? And is there an alternative instead of just go over this nurdle hurdle?
And I'll have to consult with you when we write our next paper. So nurdles are just they're the most efficient way that raw plastic resin is made. So when Dow produced those nurdles, they took ethylene and put it in one of their plants and did some chemical jiggery-pokery to it and converted it into polyethylene. And they extruded it into these little pellets. And those pellets, they take up the least space, they're easy to manipulate, they're easy to transport, they feed into hoppers, and they are the raw material for all plastics. You want to make a Lego, you start out with polystyrene nurdles, you add colorant, you add plasticizer to it, you put it in the mold, and out pops a Lego brick. Any plastic starts out as nurdles, and they all start out like that.
One last one.
Yes.
I'd like to thank you for coming,
Thank you.
but you bring up a question I think of frequently, which is, there's probably an aha moment every day. I know, there's probably an aha moment every day at a university somewhere in Louisiana of an undistinguishable factoid that the public would need to hear to change their behavior in a better way for all of us. Every day in the newspaper, there are at least 5 stories on LSU football or LSU baseball or something like that. Couldn't you work a deal with the School of Journalism to start putting out articles on these things that you're discovering as part of your research? Because I've always felt like we as taxpayers put a lot of money into universities, but behind the ivy towers. So again, you need to talk to the School of Journalism and light a fire under them.
That's a great comment. We do work with students, undergraduate students from the Manship School, and they come to my lab and they'll do an interview and write a story on it as part of their training to write stories as journalists. But maybe we need to get those stories out into the press. Thank you.